Hi friends, welcome to our last day of chapter 7. We are finishing off with a couple more identities examples, and then the rest of the chapter is reviewing. So let's power through today, and if you have any questions, make sure you ask right away. Okay, don't let this linger. This is all about your identities. So, first one, prove that this statement is true. It's an identity. Now, it looks to me like both sides, they both have two terms. The left side has fractions, but the right side has cotangent. Really, it doesn't matter what side you want to work on. I'm going to choose the right side, and hopefully I can stick on that side the whole time. So I'm choosing the right side. First thing I'm going to do here on the right side is realize that this is in terms of cotangent, and I'm going to put it in terms of sine and cosine. So I have 2 plus 2 cosine squared beta over sine squared beta. It might be easier to look at it like this to realize you need to get your common denominators. Multiplying this by sine squared over sine squared, I get 2 sine squared beta plus 2 cosine squared beta over my common denominator of sine squared beta. In the numerator, I can factor out a 2 from both terms, leaving me with a lovely identity. The reason why I'm doing this is because what's in the parentheses is an identity. It's 1. Goes to 1. How nice. This is what I'm working with now. Okay, I'm going to take a step back. Looking on the left side, I have to somehow break this up into 2 fractions, right? Because there's 2 terms being added together. So I can do that. And I need to get this sine squared away, and instead 1 minus cosine, 1 plus cosine. Kind of reminding me of using an identity and then possibly factoring that difference of perfect squares. Let's see if we can make this happen. So what I'm going to do first is rewrite this in terms of the identity, which is sine squared beta is really 1 minus cosine squared beta, that identity. Reason why I do this is because I want to factor out the denominator into the 2 terms that it is. It's a difference of perfect squares, so you get 1 plus cosine beta, 1 minus cosine beta. From here, you can break this up into each term having their own denominator. It's going to look like 1 plus cosine beta, plus 1 minus cosine beta. Because if you did the step from here to here of getting common denominators, all these terms will cancel out. So this is totally acceptable to go from here to here, which is exactly what the left side is. So I did my identity. 1 over 1 minus cosine beta plus 1 over 1 plus cosine beta equals what I found it to be. It doesn't matter the order. I can flip it to make sure that they're the same. Because it's addition, the order will not matter. So just an idea if you want. Okay, the hardest part, I believe, is from here to here. But you know this is right. If you tried to get common denominators at this step, it would leave you with 1 plus 1. Let's try this next one. This one's a little clearer. It seems like the left side is way more complicated, so let's just work there. Just on the left side. Noticing first I do not have common denominators, so let's get those. Multiplying this by sine over sine. This 1 plus cosine over 1 plus cosine. Not touching the right side. This is going to leave me with sine squared theta plus I need to FOIL. Don't forget to FOIL. You'll get 1 plus 2 cosines plus cosine squared theta. I'm going to move my equal sign over a little bit. I don't know why that's a little off. There we go. All over the common denominator of sine times 1 plus cosine. Using our lovely identity, sine squared plus cosine squared equals 1. 1 plus 1 plus 2 cosine theta is my numerator over my denominator. Notice it's now 2 plus 2 cosine, and I can factor out that 2. Leaving you 1 plus cosine. Hopefully you're kind of seeing what's going to happen here. You can cancel out these terms because there's multiplication between, leaving you with 2 over sine, which is exactly what I want. I want 2 cosecant of theta. This one actually was from chapter 6 as well. So if you really were awesome at identities, this is going to be great. There's going to be some repeats. If you're not, this is your time to redeem. Okay, we'll make it work. Let's look at our last example for identities. Left side is more complicated, so let's work there. First idea, maybe we write in terms of sine and cosine. We write this as cosine over sine. My denominator is 1 over cosine sine. My goal is to have it equal 1. Let's get my common denominators. You get sine squared theta plus cosine squared theta all over the denominator of sine theta cosine theta divided by my denominator. I want to make sure, there we go. 1 over cosine sine. Instead of dividing by fractions, let's multiply by the reciprocal. And look at my identity that pops up. That's 1. 1 over sine theta cosine theta times the reciprocal cosine theta sine theta. Sines cancel, cosines cancel, leaving you with 1, which is what I want on the right side. If you need help with identities, please make sure you ask. I am going to put a little note here. For these identities, you may have to work on both sides. As a last resort, might. So we'll talk about those in class. I'll go through them in detail. Right now is your time to practice, and I will see you in class.